Namaskar friends. In lecture 5 we have done nomenclature of alkenes and alkynes, and after that then we did nomenclature of complex locants, that means complex substituents, in which we have seen isopropyl, secondary butyl, then neopentyl, right? Then if two substituents are there, then we have to write bis, then tris. So today we will carry forward to our next lecture, to our next IUPAC nomenclature further, in which today we will see some IUPAC nomenclature with respect to some specific functional groups. Specific functional groups like acid, dicarboxylic acid, or esters, etc., in which primarily we'll see the suffix part of the particular functional group and see some examples of it, right? So today we are going to see IUPAC of functional groups. In that series, first we will see carboxylic acid, which is COOH, or we can also write in expanded form C double bond OOH, right? If you see the prefix part, the prefix part is known as carboxy, if you see the previous lecture, and the suffix is known as carboxylic acid, or oic acid. Fine. So we will see a few examples. Fine. Naming will start from here. 1, 2, 3, 4. This is the longest chain, and it has to be started only from the functional group, right? COH. So this becomes, at the second position we have methyl, so 2-methyl, 4 carbon atoms, so root name happens to be bute. Then there is a double bond bute to ene oic acid, right? Bute to ene oic acid. So here we will see. Fine. So this happens to be the first, second, third, and fourth. So I will say 3. Now this is a complex locant, and it will be cyclopropyl 2-ENYL, C double bond, it's ene, and but YL because CH2 double bond CH double bond CH in a complex locant is given by, as I've told you in the previous lecture, it is enel if it is in a substituent complex. Okay, ene, then butanoic acid. Butanoic acid, because acid will be always in the position 1. So you can say only butanoic acid, or people also can write butane 1-oic acid. People do write like that do also. So, but butane 1-oic acid is similar to butanoic acid, because OIC, it's understood that OIC will be at the first position. At the first position, right? Now we'll take the third example. Sorry. Now, the numbering is going to start from, no doubt, it will be 1 and then 2. 1 and 2, right? Now, this will be 2 because this happens to be the parent, main chain, and this happens to be the substituent. Cyclo, hexa, 1, 1, 3 because it is 1, 2, 3. 1, 3 dinyl, ENYL, dinyl ethanoic acid. Right? 2 cyclohexa, 1, 3 because at position 1 and position 3 there are two double bonds. Dinyl because this particular part happens to be a substituent, complex substituent, ethanoic acid. Right? 2 carbon atom. The root name happens to be ethanoic acid. Right? Now after this carboxylic acid, we'll see dicarboxylic acid. Right? That means you can say like that. This will be dioic acid. No. Suppose we take CuOH and CuOH and it will be ethane 1, 2 dioic acid. Ethane because 2 carbon atoms, ethane 1, 2 dioic acid, or the common name happens to be oxalic acid. Ethane 1, 2 dioic acid or oxalic acid. It is 1, 2, 3, 4. So it will be butane, 1, 4 dioic acid. This is known as glutaric acid. And the last example of this we can see means heptane, 1, 7 dioic acid. This is known as pymalic acid, common name. Pymalic acid. Fine? Okay. Now another, after carboxylic acid we will see sulfonic acid. Sulfonic acid happens to be SO3H, of which the prefix happens to be sulfo. Sulfo happens to be the prefix and the suffix happens to be the sulfonic acid itself. Sulfonic acid. Fine. We will take an example of this also. Fine. The numbering we will start from here. Alkene, because alkene has to be given a first preference over triple bond. Fine. Now it will be 1, 2, 3 and 4. 1, 2, 3, 4. Then it will be, and here 5. So it will be pen 1 in 4 ine 3 sulfonic acid. 3 sulfonic acid. Pent 1 in 4 ine 3 sulfonic acid. Now we'll go to anhydride. Anhydride is fine. This is the anhydride. Now anhydride does not have any prefix, but its suffix is also, name is anhydride, as in the case of sulfonic acid. The suffix was sulfonic acid, similarly here also it is. Now CH3 dash C double bond O dash C double bond O dash CH2 CH3. Right? The numbering will start from here. 1, 2, 3. Okay. Then it will be 1, 2, 3. It is ethanoic propanoic anhydride. Right? This is maximum number of carbon atoms, so it happens to be the parent ethanoic propanoic anhydride. Fine. Similarly, other example we will take. Fine. Suppose if we take double bond here. 1, 2, 3, and like that here it will come 1, 2, 3. It will be 2 methyl propanoic prop 2 prop 2 in anhydride. Fine. 2 methyl propanoic 1, 2, 3 propanoic prop 2 in anhydride. Right? No. Similarly, suppose one now this will be cyclohexane 2 dicarboxylic anhydride. Why? We'll go to ester. Ester. COOR is known as ester. Fine. Now we know the prefix is known. Its prefix is alkoxycarbonyl. Alkoxycarbonyl. Alkoxy. OR is known as alkoxy and carbonyl. Alkoxycarbonyl. While the suffix is known as carboxylate. Alkyl carboxylate. Or alkyl OAte. Alkyl OAte or alkyl carboxylate. Alkoxycarbonyl is the prefix, and this is, we will see some example. Right? CH3 CH2 dash C double bond O CH3. So this will be the right hand side part. That means that alkoxy part, alkoxy alkyl group is that has to be written first. Methyl, for example, suppose this is R. So take for example this is R dash. So it will be starting with R dash and then R will come here, right? So methyl 1 2 3 propane, methyl propanoate. Methyl propanoate. 8 means because it's an ester. Methyl, because here methyl is substituted. Methyl. So whatever is OR, this part, this part is written here. Right? Now, we'll take another example. CH3 CHBr dash C double bond O dash O CH3. Similarly 1 2 3. So it will be methyl 2-bromo, methyl 2-bromo propanoate. Fine. Now, similarly, we can say CH3 C double bond O CO CH2 CH3. CH2 CH3. So this will be ethyl, because this is a ethyl group, so it has come here. Ethyl, this is 2 carbon, so ethyl ethanoate. Ethane, E is replaced by OAte. E is replaced by OAte. Ethyl ethanoate. Right? We will take now a slightly more complex this. Take for example this. Fine. Now, take for example this is chlorine. So this will be 1, 2, 3 and 4. Fine. Now this will be, if I say here, it will be 1 and 2. So it will be, name will be 2-bromo 1-methyl 2-bromo 1-methyl eth 1-yle eth 1-yle 2 2-chlorobutanoate butanoate 2-bromo 1-methyl eth 1-yle, sorry, it is not ill, enyl, 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 ethinyl 2-chlorobutanoate. Fine? Okay. Which happens to be RCO. That means it is, the prefix happens to be halocarbonyl. This is carbonyl and this is the halo part. And the suffix happens to be carbonyl halide or OY, oil halide. Oil halide. Now we'll take an example. Suppose this and this. The naming will start from 1, 2, 3, 4 and 5. Right? This will be pen 2, 4 diene 1 oil chloride. Pent 2,4-diene 1 oil chloride. Fine. Now this again 1, 2, 3, 4, 5. So 3 cyclopropyl and 1 oil chloride. Or since, as I have told you previously, one position is, so we can also say pentanoyl chloride. Pentanoyl chloride. Because first position means we can write one oil also, or we can write directly pentanoyl chloride. Similarly here also. Okay? One oil. Here we have to precisely mention it. One oil chloride. Now we'll start with another one. Amide, which is C double bond O NH2. Which does not have any primary prefix, but it has only suffix, which is known as amide and carboxamide. Amide and carboxamide or carboxamide. Then generally C double bond O dash R and R, it is known as N dialkyl amide. N-dialkyl amide. Suppose we take it as CH3CH Br C double bond O dash N Here there is CH3, here there is CH3. We will start naming from here. 1, 2, 3. Then it will be 2 bromo, 2 bromo, N dimethyl propanamide, because the first position the amide is there. Propanamide. Fine. 1, 2, 3, 2 bromo and then dimethyl propanamide. We'll go for the next one. This C triple bond N, whose prefix happens to be cyano and the suffix happens to be nitrile, carbonitrile or nitrile, carbonitrile and nitrile, carbonitrile and nitrile. So you see an example of nitrile now. 2, 3, 2, 3 and 4. Cl. Here there will be Pr and here there will be Cl. So the naming happens to be, suppose if I do it from here, 1, 2, 3 and 4. Okay, so it will be 3 bromo dash 2 1 chloroethene ETHENYL. This whole part we can take as a complex locant. So it is 1 chloroethynyl at the second position. At the second position, it is 1 chloroethynyl but 3 in nitrile, right? 3 bromo, second position, there is this complex ligand, I can say it to 1 chloroethynyl, that's why I have put it in a square bracket. 1 chloroethynyl but 1, 2, 3, 4 but 3 in third position in nitrile. Yeah. Now we'll go for the next functional group. Aldehyde, which is RC double bond OH, whose prefix happens to be formyl and whose suffix happens to be carbaldehyde and Al, carbaldehyde and no. We will see some examples of it. This one we have behind. It will be from here 1, 2, 3, 4 and 5. Fine. At the fourth position we have a complex locant, cyclopro. If this double bond would not have been there, then it would have been cyclopropyl. But since a double bond is there, that means one enyl, E-N-Y-L, CH double bond CH is known as enyl. Cycloprop, if I take this 1, if I take this 2 and this 3, so enyl, cycloprop, 2 enyl, pent, we can say pentanal, because the first position itself is aldehyde, so pentanal can take as pentanal. We will take this 5-membered, so this will be 1, 2 and this will be the third, so it will be at second position there is a cyclopentyl, 2 cyclopentyl ethanal, because there is 2 carbon atom on the second carbon, 2 cyclopentene ethanal. Fine. Now we'll go with the other functional group, which is ketone. Whose prefix happens to be oxo and whose suffix happens to be on. We will see an example of it. Sorry. This happens to be chloro, happens to be bromo. Suppose, and then here it is. So the numbering will start from here. 1, 2, 3, 4 and then 5. So it will be 2 bromo, because alphabetically Br is going to come. Bromo, 4 chloro, 2 bromo, 4 chloro, pent, 3 on. Pent, 3 on. We can also write many type pentane is pentane, and E can also be replaced by 3 on. So you can write like that also. Either you write pent 3 on or pentane, E is replaced by 3 on. You have to remove it. We have to remove E and write pentane 3 on. Fine. Now we'll see then another example. A double bond. O. Fine. So the naming will be 1, 2, 3, 4, 5, 6 and 7. It is heptane. E can be replaced by heptane, 3-ene, 2,6-dione. Heptane 3-ene 2,6-dione. Heptane 3-ene 2,6-dione. Okay. Now we'll see the another functional group, which is ether, which is ROR. The prefix happens to be alkoxy. It has no suffix. We will see another example of it, CS3CH CH O CH CH3. This is CH3. Here it is, suppose if I take CH2, C double bond O, CH3. Although I will have to start the naming from here, 1, 2, 3, 4, and this will be 5. So we can see, as we have seen this, it is alkoxy. Now this is, if you can say, this is an isopropyl complex ligand. Isopropyl, if you can remember this, CH, CH3, you can say 2-methyl, na? It's 2, 1, 2, 2-methyl. So CH, CH3, this particular species is known as isopropyl. So it will be 4-isopropoxy. Poxy, because OXY I have to give. Isopropoxy pentane 2-one. Pentane 2-one. Right? 4-isopropoxy, because this is an isopropyl group. CH, CH3, CH3, CH, CH3. At the second carbon atom. At the second carbon atom, it is bonded to oxygen. So this whole part becomes isopropoxy. Fine. Isopropoxy. If you see the previous lecture, in that I have told you that CH, to which CH, from one side it is CH3 and the other side also it is CH3, right? And this is bonded to something. So this is known as isopropyl, so isopropoxy. Now we will see the another functional group, which is alcohol, which is OH. Fine. The prefix happens to be hydroxy and the suffix happens to be -ol. Okay. Now we'll see one. Sorry, cancel from here. Two, three, 1, 2, 3, 4, 5. Then this will be OH. Suppose then it will be 1, 2, 3, 4, 5. Right? Then it will be 4-methyl pentanol. 4-methyl pentanol. Fine. If I take one more example, okay, OH, then it will be 1 and it will be here. Okay. then it will be 1, 2, suppose 4, and suppose if I take here bromine, so it will be 5 and this is 6. So I will say 5 bromo cyclohexane 2 in 1 all. Hexane is replaced by 2 in 1 all. Hexane 2 in 1 all. 5 bromo cyclohexane hexane Hexane is replaced by 2 in 1 all, which happens to be H2. The prefix happens to be amino and the suffix happens to be amine. And we will take one example, CH3, suppose N, in which this is CH2, CH3, then this is CH2, CH2, CH3. So this is, suppose if I say 1, 2, 3, okay? Then this N part will be coming first. N ethyl, N methyl, N ethyl, N methyl propanamine. Propane, P-R-O-P-A-N, E is replaced by amine. Propanamine. Propanamine, because after all this is an amine. This is an amine. So N-ethyl, N-methyl propanamine. Similarly, suppose if I take another one more functional group, or one more example. Suppose this is H. Fine. So this will be, I will take 1, 2, this will be the longest carbon chain, 1, 2, 3. It will be at N position, it is the ethyl group, then N-ethyl, 2-methyl, this will be PROP, prop 2 amine, it will be, not propane amine, it will be prop 2 amine, because see, propane amine, it would have been possible only if it would have been the last root name only, right? But since it is not only the root name, but also it has one more suffix is there, so it will be prop 2 amine. Prop 2 amine. Here the amine was at a fixed one position only, 1. So it is known as 1, so propanamine. But here prop 2 amine, right? So I think so today we have done maximum examples we have done of individual functional groups. Now I think so I should take a leave, and in the next lecture number 7, in which I will take some few more complex examples, in which you will have a polyfunctional groups, a compound which is in which 2, 3 different functional groups attached in that, and that it will be, you will be able to use prefix also, suffix also, and who is given the first preference. Here we saw only a suffix, right? Straightforward suffix, and the particular functional group was given the first preference here. But now in the next lecture I will take examples in which there will be a complex compound, in which it will contain polyfunctional groups, 2 or more than 2 functional groups, and which functional group has to be given the first priority, which I have told you previously in the functional group. If you go through my functional group lecture, in that I have told you the decreasing order of priority, the priority of the functional groups. Then in that examples you'll have to again use the prefixes and the suffixes, right? So if you have any doubt, you can just write in the comment and ask me, or you can just email me, or as I've given, you can also write me a WhatsApp on it. Okay? Then I will make a leave now. Thank you for your patience and hearing all my complete lecture, and try to understand each and everything and go through those examples every now and then. Go through the examples, and it's very easy. It's very easy. You can easily do it. It's not a big deal. But in the next lecture, when we do the complex examples, that will make you much more you'll be able to understand much better, right? So thank you. Thanks a lot. Thank you. Namaskar. Thank you.